Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're going to skip our normal little intro thing and we're going to jump right into the inside of the amp so I can show you the work I've done. The last time we were here, it was just a mess of spaghetti inside here, and I wanted to clean up some of the simpler parts of this before we got into wiring up the actual inside of the amp. And so over here I've taken let me move this out of the way for now. I've taken the output transformer secondary and I went ahead and wired up all three taps. So we have our ground, 4 ohm, 8 ohm, and 16 ohm. And then over here, same thing, we got our ground, 4 ohm, 8 ohm, 16 ohm. And then here are the primary windings, and I put a tag strip on the retaining bolt on each output transformer. And then I pulled out this is the plate lead and the screen for the 7K tap. And this is the screen and the plate of the 5K tap. And I thought this was a neat way of hooking everything up. Potentially in the future, we may end up using some tubes in here that have a 5K load. So I went ahead and just pulled these out and soldered them with these tag strips. This is going to be the B plus that comes off the power supply. And I haven't decided yet exactly how I'm going to wire that part of it up. So let's go over here to our power supply. This is going to be the hot leg off of the switch of the 120 volts going into the amp. This is the neutral that's connected to the IEC connector. And let me zoom in over here so we can see that better. So this is our neutral that's connected to the neutral lug of the IEC connector. And then we've got a solder lug that's bolted to the chassis with the powder coating cleaned off, and we've got this heavy gauge copper wire that comes over and up to the ground lug of the IEC connector. This is the hot terminal up here, and it's going to be connected to our switch, and then the other end of the switch is going to get connected to the end of this wire, which we're going to obviously cut shorter and then splice the wire from the switch onto this wire. We're also going to have the filament transformers wired up over here as well. So these two red wires are the two 275 volt leads off of the secondary, which is 550 volts across them, but they're considered 275 0 275 because we have the center tap grounded over here to our star ground point. So this red wire with the yellow stripe is the center tap for the high voltage leads, and then this green wire with the yellow stripe is the center tap for the 6.3 volt heaters. So we bring both these center taps over here and tie them to our star ground point, and I'll explain that in just a second what I did there. So we have these two high voltage leads hooked up to pins 2 and 3. Then we have the 5 volt heater wires connected to pins 1 and 4. And pin 4 is where we're going to be pulling the rectified DC off of this rectifier tube. And it's going to come over here to one of these lugs of the can cap, which is the first capacitor in the filtering for the power supply. It's a 10 UF. And then we're going to take this lead that goes to the choke that's mounted on the top, the 5 Henry choke, and it's going to go to the same terminal as this rectified DC is coming to. The other side of this is going to run over here to this ground bus. And what I've done here is I've taken 3 center terminals of this 5 terminal strip and made them all a ground. And we have this heavy gauge copper wire that's soldered across all three of these terminals. And then the center terminal here is connected to the chassis, cleaned the powder coating off, and got a little star washer nut here that's getting a really solid ground for our star ground point to the chassis. So the next connection is going to be the other side of this choke that's on the top is going to connect over here to this terminal, which is the hot leg of this 47 UF cap. So the next thing it's going to go to is, and I've got two different chokes for the second choke that I may be using depending on the B plus that I measure. One of them is a 154M, which has 170 ohms across it. And then I have another one that's a little larger. This is a 2 Henry. I have a 3 Henry choke that only has 80 ohms across it. And it depends on the voltage that comes out of this B plus when we test it. So if I end up needing more voltage, I can use the lower resistance choke. But if I need to lower the voltage, I can put this higher resistance one in. So it's going to be bolted probably like this with the wires going down up here in this corner. And then one leg's going to go to this terminal right here. And then the other wire is going to go to this terminal right there. And this is going to be where our 255 volt filtered B plus comes off of, or 250 volts, somewhere around there, because we need 250 volts across the tube. And so probably going to end up using the lower resistance one, because even 260 volts would be okay since we're going with cathode biased and we're just measuring the voltage across the tube, not from the plate to ground. The last thing we need to do is we've got a pair of these filament transformers. And these are some 166 L2s. They have a primary of 115 volts and a secondary of 2.5 volts at 2.5 amps. And we want one of these for each tube. And if you live in a country that has 240 volts, you'll have to source out some transformers that work with your primary voltage. So my plan is we don't need the center tap, so it's going to get heat shrunk off. And we're going to have these two wires on each transformer. One of them will go to these two terminals, and then the other one will go to these two terminals. And then I'll bolt one of them like here, and then one of them right there. And the switch will be over here in this corner. And then these will come around over here. One of them connects to the neutral, and one of them will tie into this lead that goes to the switch over to the hot side of the 120. So once I get these transformers mounted here and get the 2.5 volts going to each of these, then I can run a twisted pair of heater wires across like this and over to the 47 tubes and the hum pots that we're going to mount over there. So again, the plan for the heater wiring is the heater wires for the 47 tubes are going to come across like this, kind of go across this no man's land across here, and then have a hum pot like right here, then have another hum pot right here, and have these 2.5 volt AC heater wires coming over here, and then these are the heater pins facing towards the back of the amp. So we'll have the hum pot, heater wires go up there, then the plate and the screen will come over to here, like that and like that. Then I'm planning on getting a piece of angle aluminum that's fairly thick and bolting it down to these two nuts, and it will give me a place to bolt the cathode resistors that look like this. And I'm probably going to make them vertical and have them mounted like this, but turned this direction like that. Well, I can't. It's going to be almost impossible to show you right now, but they're going to be mounted. There we go. They'll be mounted kind of like that, vertically. And then I'm planning on putting a vent right here in the top of the chassis for the heat to go out through the top of the chassis from those. But I've still got to go find a piece of aluminum and kind of work out the details on that. Then I'm also thinking about, for the wiring for the driver tubes, putting a tag strip across here. And I've never used one of these kind before, but they look like this with the U-shaped terminals. And I think putting one of those across here, whether I screw the ends down, there's enough surface area where I could probably just glue it right here with some contact cement. And then I'll have plenty of terminals there to connect to the grid, the screen, and all that. And like, this is the grid for the output tubes, and this is the grid for the input tubes. And so I think it's going to be pretty easy to hook all of that stuff up. And then luckily, the way I put the tubes where they look great aesthetically, the heaters are facing the front. So I can run, let me slide the amp back down. So these are the AC 6.3 volts. And then I'm planning on putting the dropping resistors from here to one terminal and from here to the other terminal, and have the resistors sitting like right in here. And then I'm going to put another vent in this area right here, so the heat from these dropping resistors can go out through the top of the amp. Because that's really the two things that are going to be generating heat inside the amp. I want to make sure I give the heat a path to escape. So let me turn this back around. So the 5 volts AC will be a pair of twisted wires that come down here, go across the front of the amp here, and then can come up to each of these input tubes. And I'll show you how I wire these up. They're going to be wired up in series. So we have two 2.5 volt heaters that'll work off the 5 volts that we're generating over here with these dropping resistors. So I've got enough wired up here now where I've got a general idea of what I have and what I'm missing. And like, I'm missing some resistors to put here. I don't have the hum pot for the output tubes, and I need to look through the rest of my boxes of parts and make sure that I have the other resistors and capacitors and stuff that I'm going to need so I can make a final parts order. And it was really so cluttered in here, I needed to kind of clean this wiring up so I could even figure out what I was needing and what I was going to do and how the tag strips were all going to work. So I think I'm in a good spot now. And I hope you don't mind that I went ahead and did some of this wiring off camera, but I think you can see what I did. This is pretty simple wiring to me. It's basically just twisting some wires up like these and running them to this rectifier tube. I'll probably wait and do the rest of this power supply wiring when I get my hum pot and can hook up the voltage to the plate of the output tube. I also need to wire up the heaters on the 27s so that we got the main current draw on the power transformer so we can accurately check the B+. And so I think at this point I've got the wiring cleaned up enough where we can start doing the rest of this together. So I do think I'm going to go ahead and mount the filament transformers up here and wire up the switch and wire up the AC to these two filament transformers and get them run down to this tag strip. And then I'll come back after I get that done and get the power switch wired up, and We may do a quick wiring little thing on this section right here to get the power to our B plus, and then pull it up on the Variac and make sure that the rectifier tube's working and that we have some B plus. Then the next thing, hopefully I'll have the parts to wire up the hum pot, wire up the heaters for the 27 tubes, and then we can really see what kind of B plus we've got once we get current running through the output tubes. Oh, and one last thing is these two capacitors here, this 47 UF and this 100 UF, they're glued down to the chassis with some Pliobond contact cement to give them some support. So I hope you're enjoying this project up till now, and hope you're enjoying my channel. If you are, please subscribe, please like the video, and we'll see you soon for more assembly work on my 47 globe tube amplifier. Have a great day.